Hey, welcome back to the second part of doing this pedigree worksheet. So let's go forward with this one. This particular question is combining your understanding of the pedigree with the idea of blood type. So we've gone through what a blood type is and how it's inherited under the multiple allele portion of the lecture. Now let's really apply that into a question. Let's see. Okay. So it says the pedigree table below shows the blood type of 3 generations, generation 1, 2, 3, a family member. Notice that some of the blood type phenotype have been given to you. So phenotype means the blood type, but we don't know what genotype it is. What is the genotype of all the individual? Give the probable genotype. So it's asking you for the genotype of all these individuals. So let's work on this. Now, if you aren't sure how to assign genotype for blood type group, go back to the lecture first and understand how to assign genotype. Okay, so this is no longer a sex-linked question. It is now autosomal. So I don't need to do XXXY because blood type has nothing to do with sex. It doesn't mean if you are a male, you're more likely to be a blood type. It doesn't have anything to do with that. It's an autosomal. And it's interesting that it uses allele called IA, IB, and little I. And these two are dominant over little I. And we know that a blood type group have a certain genotype. So go back and look at the key. And if you need to, then build the key for all the blood type group. But I'm not going to go through all those details. I'm going to assume you already know that. And then we're going to start building this. Okay, so within blood type group, what are the known ones? Okay, the known ones are actually blood type A, B, and O. So always list these two first. What is the genotype of blood type AB? What two alleles? Yes, you have big IA, big IB. What about O? Yes, you have homozygous little I. Okay, so I'm going to do those first because all these are known. So that's where you will start with a question of blood type group, your genotype. You start listing all the known ones. Now, let's work on the rest. Now, if you are A, of course you have a big IA. You just don't know what's the next one. It could be big IA, it could be little I. If you have B, of course you have a big IB. I just don't know the next one. Okay, so what would that be? I don't know. But let's look at this. His sibling actually has little I. For an individual to have little I, what does that tell him about the parents? What do you think? Yes, the parents must each have a little I for you to end up with an individual that actually is O blood type group, correct? Okay, so with that done, let's look at this individual. Oh, IA, IB. So one of the parents must have big IA. One of the parents must have big IB. Now let's really zoom out and look. And we're seeing what? That over here, it's all big IA. Over here, there's big IA and big IB. So the best guess is what? The best guess is you would put big IA here because that's where all the A's are, and big IB here because in this family, there's actually big B. Okay, now that we've done that, can we come back and figure this out? Do you think this individual will have, for the other allele, what type? Let's say mom gave the big IB. What can daddy give? Can daddy give big IA? No, because if it was big IA, big IB, this individual will be, yes, AB blood type group. So dad can only give little I. Let's draw this out. If mommy gave big IB, dad can only give little I for this individual to be B blood type group. There you go. So this individual's genotype has to be big IB, little I. Same thing for this individual. If daddy gave the big IA, mom has to give the little I. So we figure that out, okay? Moving on. Now I really want to challenge you to do the rest on your own and see how far you can get. Then come back and work on this, okay? And check the answer, okay? So take some time and see if you are able to actually figure this out. Hopefully you're back to check on the answer. Now let's think through the rationale again. So this particular family group right here on the left, for this individual to be B blood type group, she must have big IB. For this individual to have A blood type group, he has to have big IA. I just don't know what's next, okay? So let's think through what can the next be. Let's look up to the parents for us to solve this. We have no idea what the parents have, but we know there's an individual that has big IA, big IB. So one must come from this individual. The other must come from this individual. I'm just going to randomly assign this. And of course, it can be either or. So we're not going to write out all the possibility, but we're going to say because this individual, the parent set will be one with big IB, one with big IA. Now we do know that one individual has little I, and this individual got big IB from dad, so the little I must be on the other individual, okay? Now what could this individual be? Well, let's think through this. For this son, she can give big IB, he can give big IB, she can give little I. For this son, he can give big IA, she can give big IB. For this son to be B, she can give the big IB, but can he give another big IB to be homozygous B blood type? No, which means this kid must be big IB, little I. Does that make sense? Because he got the big IB from dad. That means he can only be a B blood type group with a little I. What about this individual? He got a big IA from mom. And what does he get from dad? Well, he can't get the big IB. So it has to be little I. So dad needs to have a little I to build a daughter with a because with an A blood type, because this A blood type must came from big IA from mom, and little I needs to be from the other parents. Okay, so these are all given. Hopefully that rationale makes sense. Think through this again if you didn't arrive at this. Logic is the most important thing for building these and answering these type of questions, okay? Now let's come to this side. How do we solve this side? Well, we know for anybody to be a blood type group, they have to have a big IA. The question is what's on the other side? And again, let's look at the O. O means both parents must have little I to have a, oops, what did I do? To have a, no, I don't want this. Let's retry this. Let's do this. A little I and a little I. So parents must have little I, little I. I just don't know what's the other one, right? So let's figure this out. This parent, I know, has an individual that has little I and big IA. So let's say he got the little I from number 4. Then this individual has to be what? Big IA, yes. Okay, now it comes to this individual. What will this individual be? Well, can he be big IA, little I, and still have all these offsprings? Let's see. I, big IA, big IA. Yes, I think so. Okay. And another possibility is, can this individual be little I, little I? Let's look. Can it create offspring like that? Yes. Can it create offspring with A? Yes, because let's look at this. Can give the big A, can give the big A, and the other one give the little I, correct? So it can be either this or this. What about these individual? Well, I really don't have enough information, okay? It can be big IA, little I, because it will get the big IA here and little I from this dad. Or all these can either be that or big IA, because big IA from this parent or big IA from this parent. Okay, so there's many possibility. On the exam, most likely I'm going to make it very transparent and clear that there's only one possibility. The whole goal of this assignment is so you can think through possibility and logic. Now let's move on to the next one. What is this one? This one is unique in that the trait represented by color circles are inherited in dominant allele. This is not sex-linked. Okay, so that sets up our key. Remember, you start with question 1. Is it sex-linked or autosomal? It says it's not. So it's autosomal. And then it asks, is it dominant or recessive? It says, hey, it's actually dominant. Now let's build our key. Non-affected individual, because it's autosomal, it doesn't matter. Does that make sense? It doesn't matter if it's female or male, because it's autosomal. So I don't need to do XX or XY. If you are non-affected, and this is the dominant, that means affected have it. Okay? Which means if I am going to assign big A and little a as my affected, then how would you assign your key? Think through this. Affected individual will have the dominant allele. So affected will be carrying the dominant form, while the unaffected actually will be the recessive form, because this is inherited dominantly. This is why it's important to read through the question, ask yourself the main question, then build the key, because the key now looks very different from what you're used to, which are all recessively inherited. Okay, so now that we have the key, we can come back. And now what is known are actually these non-affected individual will all have little a. So now they have only one option, which is little a. So I can list all those and then come back and figure out the affected individual. Okay, so let's go from the bottom up again. Okay, because it's autosomal, it really doesn't matter if it is male or female. What matters is little a, little a. That means this individual must be big A, little a. How do you know? Because if he's affected, he must have the dominant allele here. But the fact that he give rise to a offspring that's homozygous for little a, that means he must be heterozygous. What about this guy? This guy is affected, so again, he must have big A, and that big A must come from this parent. And so the other one has to come from this parent, and this parent only give little a. So there you go. Now, how do we figure these two out? They are affected. That means they must have the dominant allele. The next is whether or not they have the little a. Can you logically figure out whether or not they have little a or big A's? Hopefully you figured it out by looking at the sun. the son has little a, that means they both need to have a little a to actually create a son that has little a. So there we go. These are the answer for the last one. The last practice is mainly asking you to know how to set up a key for a dominant autosomal question. Let's answer the rest of the question. Are there any homozygous dominant individual in the pedigree above? How do you know? Homozygous dominant, that is this. Sorry. Homozygous dominant, right? Nope, none of these. Okay. The reason, how do you know, is because there's no probability that you can have an individual that could inherit the dominant allele from each parent and still produce offspring that are recessive, because you are seeing normal kids from all these affected individuals. Okay. What is the probability of traits appearing in offspring 7 if 7 should marry 9? Let's figure this out. Probability of the trait appearing in offspring if 7 should marry 9. So what is 7? 7 has the genotype of little a, little a. What is 9? Little a, little a. Okay. So no possibility of dominant trait, and the possibility, what is the probability of the trait appearing? 0, because there's no dominant allele, correct? And this trait is inherited in the dominant allele, so 0%. What is the probability of the trait appearing in offspring if 8 marries 10? Okay, similarly, 8 right here marries 10. What is the probability of the trait appearing? That means big A appearing. So we're going to go back to our formula. List out the genotype, list out the gametes, big A, little a, big A, little a. What would this individual give? What kind of gametes? Yes, only little a. So let's do our Punnett square. And what is the probability of the trait appearing? What is the trait again? It's the dominant one. This will have it. So 50% will have the trait. That's why this is scary. You only have one carrier, and it will for sure have 50% of its offspring having this trait. That's why dominantly inherited traits, the penetration is significant. Every generation sees it. Okay, that's it for how to apply what we have learned in chapter 12 and chapter 13 regarding the pedigree, regarding if a gene is on an X chromosome versus an autosome in one trait. Okay, moving on, we're going to apply how to do this, all of this for 2 traits. And that's it. That's the last part. We're going to do it for 2 traits, and then we're set for these 2 chapters.